Alright folks, so what we have here is I've got the two capacitors from our last Wimshurst project. I've got a linking rod here connecting the outside aluminum foil of our capacitors to each other. Without that linking rod, this won't work. You can spin it all day long and you won't see any arcs going across, and you'll think you didn't get it to work right. That's actually a really big key to make this work. The black back there is just to make sure that there's an insulator between some of the metal parts of our AC generator and this. We'll also put insulators and dielectrics all across this whole thing, trying to isolate any extra metal from our electrostatic system. Real quickly here, let me walk you around and show you what I've done for our drive system. You'll notice here that I have two different pulleys here on the actual drive bar. Right now what we're using is small to large, and we can actually reverse that and go from large down there to the small pulley, which you can see down at the bottom of that belt down there. And that's the one we were originally using in the project. So this allows us two different speeds. We can either go very fast by hooking this one up. This gives us, it takes a lot more torque at the handle, but the RPMs are very, very fast. Or we can leave that off and we can turn this one. And I just want to show you here real quick just how much energy this takes to turn, where I'll use my one finger and we'll get that thing going. So there you go. You can actually sit there and turn that thing with one finger. You can hear the snaps in the background as it goes. Alright, so one of the things I'm not liking about the plexiglass is that it's extremely temperature sensitive. In the mornings the discs are pressed really tight together when it's cold, and by mid-afternoon they're spread apart again. I'm not liking that. That really doesn't allow for a very precise machine. So 1/8 inch is way too temperature responsive to be used effectively for this, at least without having to sit there and constantly wonder what the voltage difference is going to be because of the difference in distance between the plates. Later today they'll be much closer to our combs. Right now they're farther away and our voltage is a little bit lower. So there is just one of the flaws that I saw with using 1/8 inch PVC is that you're going to have to keep this in a climate controlled room to continue this working properly. So like what I've got to do now is put all of our main discharge rods. One of the things through Gauss's law that I'm looking at here is that I'm hitting a voltage limitation with this because of the size of the rod. Now this is 5/8 inch rod. The problem is that 5/8 isn't high enough to carry the actual voltage on the surface, the skin effect basically, that's being generated by this generator. So I may have to go to, like, let's say a 3/4 or 1 inch rod right here to give me enough surface area to carry the charge that I'm looking for. And on from here, the same thing. We're going to have to build very large in diameter rods because electrostatic charge is different than normal AC or DC current, where AC and DC current typically ride inside the conductor, kind of like water inside of a pipe. Whereas electrostatic charge, there is zero net charge inside of this conductor. If you could hook a meter just to the inside of this, you'd see zero charge, even though the outside, the surface area, was completely packed full of charge. So basically, you're only using the surface area for electrostatic. No inside conductor diameter matters. It's all about surface. So we're going to increase that, like I said, to quite a large surface. I may go to 1 inch, all the way across from our pickups, all the way down to our capacitor bank. What I'm going to do real quick here is we're just going to fire this thing up and just give it a quick test spin with the original capacitors from the last Wimshurst. The problem with this is going to be is that is the biggest spark gap that I can basically get. I can go a little bigger than that due to the dielectric constant of the PVC, the thickness of the PVC and the aluminum foil, which allows only for so much charge before you start burning through the dielectric of the PVC. If I put the spark gap too much bigger than this, you turn the machine just a couple revolutions and you can actually hear a crackling sound all through the capacitors, and that's actually burn through happening, where the charge is too high, the voltage is too high for the dielectric, and it's actually burning through, creating weak spots or carbon points inside the dielectric. So that's about as big as we can go with these capacitors. Once I got some much bigger capacitors with a higher kappa material in between the induction plates, we'll be able to throw much bigger sparks from this. So let me go ahead and set up the camera and we'll turn this thing on and show you what it looks like in action.